I see Raman Research Institute really standing out amongst institutes, primarily on this one single capability of carrying out frontier science supported by fairly high end technological capability in house with our own engineers and technical people and scientists working together.
The main responsibility of engineering group is to support the technical requirements for the scientific experiments undertaken by several scientific groups across the institute.
The electronics engineering group in RRI is one of the very unique group where people have expertise all the way from antennas, analog electronics, digital receivers, and building computer programs and doing analysis and doing even astronomy in some several cases.
Our laboratory has a long standing history of about 3 decades, starting from 10.4 meter radio telescope which was installed, commissioned in the premises of Raman Research Institute. Followed by that, there was one more major activity which the engineering group took, was to build a wide band 21 centimeter receiver systems for the giant meter wave radio telescope which is there in Pune. We in RRI built the entire electronics for all the 30 antennas of GMRT dish. The third project, which was again one of the major activities, was to build a telescope which by itself was unique in its concept design. This was designed, this was developed by Govinda Swarup and his colleagues in GMRT. We took up the responsibility of building it in an RRI, convert paper design to reality. The digital group of our group took up major work involved for MWA project. MWA project is again an international project dedicated for radio astronomy at low frequencies.
Electronics engineering, electrical engineering has been supporting us very well. I am very happy to say that we have dedicated sections for all these facilities in the institute.
So, the digital receivers are developed for cosmology applications, one being SARAS, where we are trying to detect a signal in the frequency range of 40 to 200 megahertz. The second being to avoid the interference from the earth stations, where we have lot of FM stations all throughout the place. We are planning to propose a payload to ISRO which is called Pratush, which operates in the frequency range 55 to 110 megahertz. So, the same digital receiver what we build as a generic platform is catering to both SARAS as well as Pratush.
This Polix instrument is entirely built in-house at RRI.
Currently, we are in the police integration area where this place is especially designed for ESD compatibility and safe environment for flight PCBs.
So, the challenging part is it's very difficult to see through the naked eye. So, we are handling such type of the wires in wiring of these wireframe detectors.
This digital signal processing domain is like a heart of the system. So, when the signal comes to our system, so the processing electronics should make sure that the signal is being analyzed and processed and recorded.
We developed the instrument in several steps. We work closely with ISRO and we follow their methodology of how they develop their instruments. We learn from them.
this telescope will have 130,000 antennas. Each one of the antenna signals will be amplified, digitized, and combined to form the images that we are going to see.
Which would be built in Australia and South Africa region. The hardware part has been given to us, and we are working for the firmware and software development of it. Almost 157 terabytes of data per second would be received from the sky.
Recently, I worked for a project called Brain-Computer Interface, which is nothing but an interface which connects your brain signals onto the machine. So these are the very weak signals which emerges out of your brain gradually. And then what we have learned to do over here is how to capture these signals, condition them, and then how to use them to any robotic systems. So these are for the people who have some neurological diseases or who have some accident earlier and for whom the signals are not being traveled from the brain to the muscles.
One of the advantages of RRI is that RRI has excellent electronics divisions with experts which they have capabilities which are hard to find anywhere else. And for us this was a very important thing because we develop a lot of instrumentation as studying mechanical properties of neurons or other cell types.
Any system designer, no, for that matter, whenever our systems, we put a lot of effort in making our systems work to the required specifications. Once you see the system is working and deployed without giving any problems, and we are not called for servicing those instruments, that is the really happiest moment for us, so that you get good science out of it. For example, MWA, what we designed for Western Australia, even now it is almost 12-year-old instrument, it is still working very well and good science results are coming out.
It is called SWAN project, that is Sky Watch Array Network, where more than 100 or 200 students got involved in this. So what we did was we made some 10 individual receiver systems and it is deployed in our local observatory Gauribindu Radio Telescope. Students came there from different ISERs, NITs, IITs, and they were given hands-on training like how to, from the antenna to the analysis, how to analyze the data. Till that point they were given training and the instruments will be moved to their institute and they will be training the next successive students there.
We try to build systems for them, for their experiments, and see that the scientific activities go forward and it produces something useful for the entire community.